When you think of prehistoric monsters, what comes to mind? Towering dinosaurs like the T-Rex, with its bone-crushing jaws. Or maybe giant sea creatures lurking in the deep. Well, I'm here to tell you that the most terrifying, most powerful monsters in Earth's history were completely invisible. We're going back in time, way before the dinosaurs, to an era when the planet was ruled by microbes. These weren't just tiny germs. They were the original apex predators, the true titans of the primordial soup. Let's get our heads around this. In a world without animals or plants, a microbe wasn't just some background organism. It was everything. Imagine a single cell, but on a scale that's hard to comprehend. Some of these ancient cells were giants of their time, visible to the naked eye. They were the hunters and the hunted, locked in a brutal microscopic war that had been raging for billions of years. Forget claws and teeth. These creatures fought with chemical weapons and biological armor. You've probably heard of the Cambrian explosion, that incredible burst of life that gave us the ancestors of modern animals. But have you ever thought about it from a microbe's perspective? For them, it wasn't an explosion of new life. It was an invasion. Suddenly, their world was filled with complex, multicellular organisms. This kicked off one of the greatest evolutionary arms races in history. Microbes developed new ways to attack, to infect, and to consume, while the new animals had to evolve defenses just to survive. It was a single-celled world fighting back, and the battle was fierce. How do we even know about this? We find their ghosts. Scientists look for fossilized shadows in the ancient rock record. These aren't dinosaur bones. They're subtle chemical signatures, fossilized microbial mats called and the microscopic imprints of the organisms themselves. It's like being a detective for a crime scene that's billions of years old. By piecing together these clues, we've uncovered evidence of prehistoric plagues, massive microbial outbreaks that literally changed the world. These weren't just localized events. An ancient microbial plague could alter the very chemistry of the oceans, or pump enough of a certain gas into the air to change the entire planet's climate. They were the unseen ecosystem engineers. We often attribute mass extinctions to asteroids or volcanoes, but some of the most devastating extinction events in Earth's history were likely driven by these microscopic monsters. A single species of bacteria blooming out of control could suffocate the oceans, poisoning everything in its path. In that world, a microbe was far more powerful than any T-Rex would ever be. They were the silent architects of bold extinction and the rise of new life that followed. Now here's where it gets a little eerie. These ancient lineages didn't just disappear. Many of their descendants are still with us today. Scientists have found microbes living in extreme environments like volcanic vents, deep-sea trenches, and under Antarctic ice that are essentially living fossils. Their genetics can be traced back for billions of years. These incredible survival stories give us a direct window into Earth's deep past. By studying them, we're unmasking the living relics of the microbial world, organisms that have survived everything the planet has thrown at them. And this isn't just ancient history. The strategies these microbes developed to survive, the ability to share genes, to develop resistance, to go dormant for millennia. The same strategies we see in today's superbug. The fight against antibiotic-resistant bacteria is, in a way, the modern chapter of this ancient war. The eerie connections between prehistoric plagues and the public health crisis we face today are a stark reminder that this battle is far from over. These microbes have been playing the long game, and they are masters of adaptation. So, why does any of this matter? Why spend time digging up the stories of billion-year-old germs? Because understanding our planet's microscopic past is absolutely critical for our future. The rules of this ancient arms race still apply. By studying how these prehistoric plagues started, spread, and ended, we can learn invaluable lessons for predicting and fighting future pandemics. It helps us understand how life responds to crisis and how resilient it can be. The impact of this microscopic past is all around us, written into our own DNA and the very air we breathe. The world we live in today was shaped, molded, and terraformed by these invisible forces, and the hunt is still on. Scientists continue to explore the most remote corners of the globe, drilling into ancient ice cores and sampling the deep-sea floor, searching for undiscovered microbial monsters. Who knows what secrets about life, extinction, and survival are still locked away, waiting to be found? The story of our planet is, and always has been, a microbial one. Thanks for joining me on this journey into the deep past. If you found this as fascinating as I do, make sure to hit that like button and subscribe for more deep dives into the hidden history of our world. See you next time.